All right, we're going to look at some more trinomial factoring. And in this case, we're going to look at trinomial factoring where the a variable is no longer a 1. Everything we've done so far has an a value of 1, which implies that every parabola that we factor has to be of the parent form and shape. But we know that there can be many other parabolas where the a value is different. So we're going to show you how to deal with that case. And it isn't quite as simple as the earlier ones, but it does have a pattern. It does have a step-by-step process, and we're going to show it to you now. Okay? So in earlier work that we did, we learned a relationship about C and about this term here, that these are multiplied together to obtain, two numbers are multiplied together to give you the negative 18. We also learned that two numbers are added together to give you the value of the b term. And so I would be looking for two numbers that multiply to negative 18, but would add to negative 3. And I can think of those in my head. There aren't many numbers that multiply to negative 18, and I think this would be our factoring of this. This number and this number add together to give you negative 3, and those two numbers multiply to negative 18. This is a very straightforward process. Now you'll notice that if we apply that same rule over here to this one, we would be looking for two numbers that multiply to negative 1 but add to 4. And immediately we can see that there's a problem there. And so there's something to do with this guy out here. This guy adjusts things. So let's show you how it adjusts things, and then we'll teach you how to factor these things. So the first thing to show you is how we multiply two binomials, how they make a trinomial, and then to kind of work it backwards. So as you know, first, outer, inner, last, or basically just distribution. So we get 5x squared plus 5x minus 1x minus 1. We notice that the middle group here is combined, and so we get 5x squared plus 4x minus 1. So we see a couple things taking place is we see that middle term again getting combined. We see how this first term is made here and here by the multiplication of the 5 here and the 1 in this position. So we're learning a little bit more about the mechanics of how things are made, and that's how you would work it backwards. So let's do a quick summary. We're noticing again, this is made by addition. This is made by multiplication, and it's made by multiplication, if you look carefully, of the first term and this value right in here. Alright, so let's try out our new situation. So first of all, we notice a lead term different than 1. Things slightly change in our basics here. We are looking for two numbers that multiply to 24. Now you say, how did that come about? Again, we learned that it's the multiplication of these two guys and two numbers that add to the middle term of 11. And so where does that come from? Comes from right in here. Now I can find two numbers that do multiply to 24 and add to 11. Those are 8 and 3 in both cases. Now watch what I'm about to do with this. I'm going to rewrite it slightly differently. 2x squared. Now those aren't my answers. You watch what I'm going to do. I'm going to put down my 8x and my 3x, and I'm going to place them basically as two items into my expression there. The next thing I'm going to do is kind of divide my expression in half. and factor each half individually. I'm going to pull out 2x, and I'm left with x plus 4. Over on the other side, I am going to pull out, looks like a 3, and I'm left with x plus 4. Now in doing this, you'll notice that I'm multiplying the 2x times x plus 4 and the 3 times that. This can be written as 2x and 3 are both multiplying by x plus 4. This is the factored form of the trinomial we're looking at up top. And just take a quick look at it, see if this idea works. Do you see how the lead terms would multiply to 2? Do you see how the back terms would multiply to the 12? And they will produce the exact number that we want. Let me go through it again. These are a little bit new and a little bit tricky. Let's do one more together. All right, on this one we're looking for two numbers that would multiply to be 10. Again, you might say, where does the 10 come from? Because of the lead coefficient, I multiply it by that back term to obtain the 10. And then it has to add to a total of -7. Now again, those aren't very difficult values to obtain. Again, the -7 is here. So it's got to be a 5 and a 2, and it looks like a -5 and a -2 are going to obtain that. Now what is a little bit different is that you're going to, instead of just simply finding those as your factors, you're going to split up the middle term into two pieces and then work from there. Do you see what I'm referring to there is that I'm taking this middle group here. This makes up the -7. The last thing I do is I put a line down the middle here to help me remember I'm going to factor this in groups. Remember, this was made by a distribution process, so it came from groupings, so I'm going to put it back in its groupings. So the only thing I can pull out here seems to be an x, so 2x minus 5. Now I have a choice as to take out, actually the only thing I can take out of this group is a 1 or a -1. And I'm going to take out a -1, and that way I get the same answer, 2x minus 5, as I do in the other case. If you factor this correctly, you will always get two identical items. And that's what allows you to say, in a distribution manner, x and -1 both multiplied by 2x minus 5. This is called factoring by a grouping technique. Good luck with these.